Hello friends. Hello friends. Let us now learn some important points about the filter thickness. So we have learned about the different types of filters, added filters and inherent filters. Now let us learn some important points about the filter thickness. After selecting a filter material, usually aluminium, the next step is to determine the appropriate thickness of the filter. The percentages of appropriate thickness or percentages of X-ray attenuation or percentages of attenuation of monochromatic radiation or actually X-ray attenuation with 1, 3, 10 millimeters of aluminium is shown in this picture, in this table. Okay. So this is the table which is showing the percentage of attenuation of monochromatic radiation by aluminium. So at 1, 2, 3 using 1, 2, 3, 10 millimeters of aluminium. So if you see the 2 millimeters of aluminium absorbs nearly all photons, 2 millimeters of aluminium nearly all photons if the energy is less than 20 kilo electron volt. So most of the advantages of filters are achieved by this 2 millimeter thickness. So an aluminium filter with almost 3 millimeters thickness has no advantage because this 3 millimeters thickness uh, it has no advantage, but it is causing excess filtration, which is a disadvantage, because if you see the most of the energy is lost by this 3 mm filters. So not just low energy radiation, but most of the energy of 30, 40 and 50 kilo electron volt energy is also lost by using 3 mm filters. So if you see in the right column, with by using 10 filtration, there is excessive filtration is seen. So if you see the overall effect of this chart is that the overall attenuation of the beam primarily by absorption of high energy photons. Here at 10 millimeters, you can see overall attenuation of the beam occurs primarily by absorption of high energy photons, because all low energy photons have already been absorbed by these thinner filters. So the quality of beam is not significantly altered, but its intensity is greatly diminished. So this lengthens the time which is required to make an exposure, which increases the likelihood of patient moving during the examination. So on increasing the photon energy, the percentage of attenuation decreases. There are two important things that you can get from this table. One, on increasing the photon energy, the percentage of attenuation decreases. Number two, as you increase the attenuation, the filtration also increases. So with 3 mm and 10 mm, it is not much desirable when compared to 2 mm, which is most desirable type of filters. So thickness of aluminium filters increases, the attenuation or percentage of attenuation of photons also increases. So 2 mm thick aluminium filters absorb all photons of energy less than 20 kilo electron volts. So this is more desirable, but overfiltration occurs from 3 mm and also the 10 mm aluminium filters. So if you see 30 kilo electron volt energy is also absorbed completely by almost completely by 10 millimeters filters. So over excessive filtration occurs, which is more disadvantageous than having any advantage. Then the next thing, we have to draw a uh, graph showing the radiation intensity on x-axis and photon energy on y-axis. So this is a this is an we have to see the effect of aluminium filters on 90 kilo electron volt polychromatic X-ray beam. So this is an unfiltered beam. This unfiltered beam composed of spectrum of photons, many of which have energies between 10 to 20 kilo electron volts. The highest point of this curve is 25 kilo electron volts, which is the maximum intensity, which where maximum intensity of X-ray photon is present at 25 kilo electron volts. This is unfiltered beam. Then when aluminum filter is used, filtration will reduce the total number of photons in the X-ray beam, but more importantly, it selectively removes a large number of low energy photons. So as a result, the intensity on the lower side of the curve is reduced considerably more than the intensity on the higher energy side of the curve. The highest point, which is 25 kilo electron volt in unfiltered beam, is shifted to 35 kilo electron volt in filtered beam. Overall effect is there is an increase in mean energy of X-ray beam. So unfiltered X-ray beam spectrum is around 10 to 20 kilo electron volts and highest peak at 25 kilo electron volts. Filtration removes lower energy photons. Intensity also decreases on the lower energy side and peak increases, so mean energy increases. So then this is about the filter thickness. Thank you.